Hello, Longhorns. Today we are going to take a look at the 5th 6 weeks test review, and I'm going to work through each problem for you so that you can see how to do each problem and what to expect on the test. Okay, so let's start with problem number 1. Okay, so we're going to use the law of sines to find angle A. We have side A, we have side B, and we have angle B. So I'm going to, since I'm looking for an angle, I'm going to use the law of sines with the angle on top. And that's going to look like this. Sine of 37 degrees divided by side 5 equals sine of A divided by side A, which is 8. Now I'm going to just cross multiply and divide by 5, so I'm multiplying sine of 37 times 8 divided by 5, and I should get sine of A equals, and that equals 0.9629. Well, that's the sine of A. To find A, I have to do the sine inverse, or arc sine. So let's put that in the calculator and see what we get. All right, so if your calculator is in radians, you might get the answer that angle A is equal to 1.297. Well, that is a radian and not a degree. So since our problem is in degrees, we need to convert that. So you either need to have your calculator in degree mode, or you can do a degree conversion by multiplying times 180 and dividing by pi. That is going to give you approximately 74 degrees. With problem 2, we're going to use the law of cosines to find AB. AB is basically side C. So we can just go ahead and label that side C. This is side B, and this is side A, using the labeling convention that we've been using. All right, so using the law of cosines means if I'm finding side C, it's going to be C squared equals A squared plus B squared minus 2 times A times B times the cosine of 107 degrees. So I need to put all of that in my calculator to find C squared. That equals 384.94. And to find C, I need to take the square root of that. And the answer I get is 19.62, which makes sense when you look at the sides here. You always want to check your answer to make sure that it makes sense. This is side 9, this is side 15. So you know that the third side needs to be a little bit bigger than 15, and it is. So it's within a reasonable range for a correct answer. Okay, so in problem 3, we need to determine the number of triangles that can be formed. We need to find the value for h. H is the height of your triangle. And once we find h, then we can compare side A to h to see how many triangles we've actually formed here. All right, so the formula for that is h equals b sine A. That will give us the height of the triangle. Since we don't have a B, but we have a C, we can also substitute C in for B. So we could say H equals C sine A also to get the height. So let's go ahead and plug those values in and see what we get for H. All right, so 16 sine of 30 degrees equals 8. So H is 8. And since A is less than H, because 7 is less than 8, we have no triangle formed. So just remember for the test on Thursday, you have to find the value of H before you can determine how many triangles are formed. Because you could have no triangle formed, or you could have one triangle formed, or you could have two. So it depends on what the values are for your sides and your height of your triangle. So if you don't know what the height of your triangle is, you're not going to be able to determine how many triangles you have. Okay, so number 4 is super easy. We have vector 3, negative 6, and we have vector negative 2, 7, and then we have that C is equal to A minus B. So all we have to do is subtract A minus B. So 3 minus a negative 2, 3 minus a negative 2, and then we have negative 6 minus 7, and that gives you 5, negative 13 as your new vector. And that's all there is to number 4. And then number 5 is what is the magnitude? Well, that's just taking the square root. We're using the distance formula here. 5 squared plus a negative 13 squared. And I guarantee you that if you don't put that negative 13 in parentheses inside your radical, when you put that in your calculator, you are going to get the wrong answer. Even though I know I have said that 1,000 times, I still had many students, many smart students who did not enter that correctly into their calculator, and they got the wrong answer on the last test. Please, please, please make sure that you put that negative 13 in parentheses if you're going to put this in your calculator and calculate it. Another thing you can do to just make sure that you don't make that mistake is square these first before you put them underneath the radical. And that way you know that you've got the right number inside there and you're not going to make that mistake. So the answer to number 5 is approximately 13.93. And if you rounded that up to 14, I would not be upset. Okay, so for problems 6 through 9, all you have to do is tell whether the equation forms a circle, a parabola, an ellipse, or hyperbola. So I'm going to show you a quick shortcut of how to do that. It makes the problem very simple to do. We do not have to convert all of these to standard form to determine what the shape is. You do, however, need to look at your squared terms. And so I'm going to give you a little shortcut hint that's going to help you. For number 6, when I look at number 6, I'm going to look at this squared term right here, and I'm looking at the y squared term. And if I were to convert that to standard form, this would not work. This would have to be a minus 15, just so you know if you're trying to do that. Okay, so I'm looking at my squared terms, and since my x squared and my y squared are both squared, and since my sign in between them is a positive, so that's a plus sign, we're adding those together. And since the coefficient in front of the x and the y are the same, they're both ones, that makes this a circle. All right, so let's look at number 7. In this particular equation, we only have one term that is squared. If you have only one term that's squared, then you have a parabola. Okay, for question number 8, here I have an x squared and a y squared and a plus sign. So that could be a circle, but it's not, because this term here has a coefficient of 10, and this term here has a coefficient of 1. Since the coefficients are different, that makes this an ellipse. Okay, and then number 9. Number 9 is the last one. Here we have two squared terms. And two squared terms, if they have a minus sign here, that means it's a hyperbola. And that's basically all there is to problems 6 through 9. Now you could do complete the square and change all of those into standard form, but it's really not necessary. Okay, so for problem number 10, you have to identify the center and radius of the circle. And so we know that the center is HK, and 5 is our H, and 3 is our K, and that the equation is x minus h squared plus y minus k squared equals r squared. That's the equation of our circle. So if I have a plus 5 here, that means that this must be an x. This must be an x minus a negative 5. So my center x value is actually, my h value is actually going to be a negative. All right, so my center is going to be negative 5, comma, and here my k is going to be 3. So just remember, when you're taking those values out of those parentheses, the signs change. All right, the radius is the square root of 49, which equals 7. So our radius is 7. Okay, for problem number 11, it says find the center and vertices of the following ellipse. All right, so the center, again, is the same as for the circle, HK. We have H here and K here. So just remember, when you're taking the numbers out for your center, you have to change the sign. So that's going to be a positive 3 and a negative 5. That's my center. All right, so now it also wants the vertices. Well, you remember that this value right here is your a squared, and this value here is your b squared. And for an ellipse, the main axis is going to be your a squared. So in this case, our main axis is under the x squared term. So our main axis is going to be horizontal. And since our main axis is horizontal, that means that I'm going to add or subtract the square root of a squared, which in this case is going to be 4, from my x value, which is 3. So my first vertice, I'm going to subtract 4 from 3, and I'm going to get a negative 1. My y value for my my vertex on the left is going to be the same value. It's still going to be -5. The y value is not going to change. Then I have to do that again for the other vertex. So I'm going to, this time I'm going to add 4 to 3, and I'm going to get 7. Now you could draw a picture of that if you want to by graphing it. Let's just draw a real quick sketch here, what's happening, so that you can see what's happening here. 1, 2, 3. I'll just do a real quick sketch here of this ellipse. All right, so the center is at 3, -5. So 1, 2, 3, -5. Okay, and then we're going to have an A of 4. So we're going to go out 1, 2, 3, 4. 1, 2, 3, 4 with the X. Get a better dot there. And then the B value is up 3 and down 3. Going into the next problem here a little bit. Okay, and there's your ellipse. All right, so it's kind of a rough sketch, but you get the idea. All right, so as you can see, the B value, the B doesn't really have anything to do with these main vertices. What we're looking for are these points right here. So -5 was one of them, and the other one was 7, -5. So you can kind of see a picture of that here. All right, I'm going to go ahead and erase that since it's covering up this other problem. I don't want that to happen. So you can get an idea of drawing the sketch yourself and getting your ellipse and seeing what the vertices are. You can do that, not a problem. Okay, so for problem number 12, we have to write an equation of a hyperbola with the vertices at 2, -4, and 10, -4. I believe the printed copy of your review might have had that this first coordinate right here might have been switched. That was a typo. It should be 2, -4, not -4, 2. So if your copy has that typo on it, make sure you fix that. It should be 2, -4, and 10, -4. The value of A is 9, and the value of B is 4. And we're supposed to write a hyperbola with this information. All right, so the first thing you want to do is find the center. We need the center. So you can find the center by adding the 2 and the 10 and dividing by 2. We're actually using part of the midpoint formula here, but just for the x value, because as you see the y values are -4, so the y value for your center is also going to be -4. So we're only finding the x value. So 2 plus 10 is 12, divided by 2 is 6, comma, -4. That's going to be our center of our hyperbola. So let's look at the equation of a hyperbola real quick. We have, it's either going to be x minus h squared minus y minus k squared divided by some value equals 1, or it could be the other way around. We could have the y squared term first. So what you need to determine here before you start writing your equation is which way is this hyperbola opening? Is it opening up and down, or is it opening sideways? If the hyperbola is opening sideways, that means that it's opening along the x-axis, and if it's opening up and down, then it's opening along the y. So that matters when you're writing your equation. If you get that backwards, then it's going to be wrong. So let's just graph the points first, and then you can tell which way it's opening so you don't make this mistake on the test. Okay, so we have 2 vertices and we have the center. So let's go ahead and graph those. So I'm going to just, I'm just going to add some lines here to this graph that I created, and just extend it out a little bit here. Okay, so the center is at 6, -4. So 1, 2, 3, 4, 5, 6 down 1, 2, 3, 4, 6, negative 4. Our center's way down here. Okay, then we also have the points 2, negative 4, and 10, negative 4. So we need some more points. 6, 7, 8, 9, 10, negative 4. All right, so this is my vertex. This is my vertex. These right here, these are my vertices. This is my center. So that means my hyperbola is opening sideways. Just like that. All right, so since it's opening sideways and all of my points are running parallel to the x-axis, that means that my x term is first. So when I write my equation, I'm going to write x, and then I have to put in minus 6, because that's my center, squared, and then a minus sign, because it's a hyperbola, y minus k. And since k is a negative 4, we're going to do minus a negative, which becomes a positive. Don't forget you've got a 1 out here. Now you got to put also your a squared and your b squared. A squared always goes underneath the first term. So a squared in this case is going to be 81, because 9 squared is 81. And b is 4, so 4 squared is 16. And that's all there is to writing that equation. Okay, so for problem 13, it says, write the following equation in standard form. Hint, identify the conic and then complete the square. All right, so to identify the conic, all we need to do is look at the two squared terms. And since these are two squared terms, it's not a parabola. It has a plus sign in the middle, which means it's either a circle or an ellipse. And since these two coefficients are different, it's an ellipse and not a circle. Circles have to have the same coefficient. So we can go ahead and begin putting our x term values together. So we have x squared plus 6x. We'll put those together, and then we'll put the y terms together. 4y squared minus 8y. And we're going to go ahead and move this 9 to the other side of the equal sign, and we're going to subtract 9 on the other side. So we went ahead and moved our constant to the other side of the equal sign. So when we begin completing the square, it makes it a little bit easier to keep track. So let's start with the x. And we're going to do x squared plus 6x. Now, if you remember, for completing the square, you take half of 6 and square it. So half of 6 is 3, and 3 squared is 9. So I'm going to add 9 here to make a complete square. And since I'm adding 9 to this side of the equation, I also have to add 9 over here to this side of the equation. All right, so this one's a little bit trickier because now I've got to factor out this 4, because remember, when you complete the square, you can't have any coefficients in front of your squared term. So we're going to have to factor out that 4. So we're going to factor it out, and that leaves us with y squared minus 2y. And when I cut 2 in half, I get 1, and when I square it, I get 1. So I'm going to add 1. Now this is the tricky part here you have to remember, because on the right side we have negative 9 plus 9. But to take care of this 4 that's here and this 1 that's here, this is actually 4 times 1. So we have to add a 4 times 1, not just 1. We're not just adding 1 to both sides. We're adding 1, but we also have to multiply the 1 times 4 to take into consideration that we had to factor out the 4. All right, so now we're ready to rewrite our trinomials. This first trinomial right here, this x squared plus 6x plus 9, that's going to be x plus 3, the quantity squared. Because remember, half of 6 was 3, and 3 squared is 9. So that's the number that goes in that one. This one, we have a 4 on the outside. We've got to keep that. And then we have y minus 1, the quantity squared. Because half of 2 is 1, and 1 squared is 1. And we have a minus sign here, so this also has to be a minus sign. All right. That's going to equal, now I'm going to just combine all my like terms here. I have a negative 9 plus 9, well that's 0. And then I have plus 4, well that's 4. All right, so since this is an ellipse, we have to make sure that our ellipse is equal to 1. So what I'm going to have to do is I'm going to have to divide everything in the equation by 4. So my final equation is going to be x plus 3, the quantity squared, over 4, plus, and if you notice here, these 4's cancel out. So we get y minus 1 squared equals 1. And that's all there is to that equation. And that's it.